Hi everyone, welcome to this Python tutorial. Today we will build a simple but useful app called the 20-20-20 Eye Care Timer. This app helps protect your eyes by reminding you to take breaks every 20 minutes. The rule is easy. Every 20 minutes, look at something 20 feet away for 20 seconds. In this video, I will show you how to create this app step by step using Python and Tkinter. Let's start by taking a quick look at the app. It opens in a small window, set by default to 20 minutes, counting down second by second until it hits 0. You'll see three main buttons: an exit button to stop everything, a reset button to restart the timer, and a pause button to take a short break. And here's the cool part: even if you close the window, the app keeps running in the background. When the timer hits 0, the whole screen goes black for 20 seconds. After that, it switches back to normal and the countdown starts again. And this loop keeps going for as long as you're using your device. First, I created a Python script file in VS Code and got ready to code. I start by importing the Tkinter module, which I'll use to build the user interface. So I write import Tkinter as tk and also import ttk for styled widgets. Next, I create a class called iCareApp. This class inherits from the Tkinter tk object, so it can use all the window features easily. Inside the class, I set the window title and size using title and geometry. Then I call main loop to show the window and keep it running. After that, I create an instance of my iCareApp class and run the app. Boom! I get my first window frame on the screen. I can also change some settings, like the background color to black, and run it again. And just like that, the window appears again, this time with a black background. Now, I want to set the window position to be centered on the screen by default and make it non-resizable with a fixed size. So, first I set variables app width equals 600 and app height equals 400 pixels. Next, I get the screen's total width and height information. After that, I divide the total screen width and height by 2, then subtract the app's width and height respectively. This will calculate the exact position to center the window. Then, I set these values using self.geometry function with an f string, combining the app width and height with the calculated x and y positions. I also call self.resizable false to disable resizing in both width and height. Finally, I run the code. Perfect! The window appears centered on the screen and cannot be resized from the frame's edges. Then let's create some widgets that will appear on my app window. First, we'll create a text label that sits in the middle of the window and shows the countdown minutes. We call the ttk label function and set a few options. The master is self, because it needs to appear on the main window. For now, I'll set the text to 00 as a test. The font will be Cascadia Mon, which is my favorite style, and the font size will be large, around 100 pixels. The background color will be number 333 for a dark tone, and the foreground will be number 222 for white text. To display the widget, we pack it with self.timer.pack and set expand equals true so it fills the available space. Let's run it. Yes, it shows up perfectly. Now, let's create the button widgets. First, we'll make a frame widget to hold all the buttons. We pack the frame with fill equals X so it stretches across the window horizontally. Let's create the first button, exit button. We call the ttk.button function with the master set to our frame. The text is exit. The font is Cascadia Mono, size 16 pixels. And the relief is set to flat. The background color will be dark red to give it a bit of a danger look. The foreground color is white number FFF. And the cursor style is hand 2, so it changes to a hand when hovering. The command for this button is self.destroy, so clicking it will close the application completely. We pack the exit button and run the program. There's an error. Let's review the code. I typed relife instead of relief, and I need to change TTK to TK. Now we run it again. Yes, it works. To improve the layout, we set fill equals X and expand equals true, so the button fills the row nicely. Now let's duplicate this button 3 times to create a reset button and a pause button. For the reset button, the background will be Dodger blue and the command will call a reset time function. For the pause button, the background will be orange and the command will call a pause function. For now, both reset time and pause functions will just have a pass statement as placeholders. We pack all the buttons to make them visible and run the script. Right now, the buttons are stacked in rows along the x-axis. I actually want them in columns, so I change the pack option to side equals left for each button. Run it again. Perfect. That's exactly how I wanted it.
Alright, now that we've finished the GUI part, let's move on to the functional part of our timer. First, I'm going to set a variable called time to 20 times 60. That's basically 20 minutes, but in seconds. Next, I'll create 2 more variables, paused equals false, and running equals false. Now let's create our countdown function. Here's the logic. If the paused variable is set to false, we'll run the countdown block. Otherwise, we'll skip it and just let the update run once per second. When the timer isn't paused, I'll set running equals true. To calculate minutes and seconds from our total time, I'm going to use Python's built-in divmod function. We pass in the total time, divide by 60, and it gives us two values. The first is minutes and the second is seconds. Now we'll insert those values into our label widget's text. This format specifier means always show two digits. So if it's 5 minutes, it'll show as 05. Same thing for seconds. Next, we'll add a condition. If time greater than 0, we'll decrease time by 1 and call this same function again after 1 second. It'll keep repeating until time equals 0. Once the time hits 0, we set running equals false. And we call a function named breakScreen. We haven't made that yet, so for now, I'll just create the breakScreen function and put a pass statement inside. To actually try this out, I'll call the countdown function inside the init method. That way, the countdown will start automatically when the app launches. Let's run the script, and yes, it's working. The timer is counting down, second by second. Now, let's build the breakScreen feature. First, we set the paused variable to true. Then, we create a new class called breakScreen. This class goes right at the top of the file, and it inherits from tk.toplevel. Inside its init function, we add one argument, onEnd. This is the function that will run when the break time ends. We call super, giving us access to all the features of top level. We set the duration to 20, meaning 20 seconds of break time. And we store the onEnd argument in a variable, so we can use it later. Now, some important window settings. Full screen equals true to completely fill the display. Topmost equals true to keep the break screen above all other windows. And for the visuals, background set to black, cursor hidden for a clean, distraction-free look. Next, we create a label widget to show the countdown. We set its text to the current duration. Give it a black background, white text, and the font Arial, size 100. We pack the label, so it's perfectly centered. Then, we write the countdown function. Here's how it works. If the duration is greater than 0, we update the label. Subtract 1 from the duration, and use the after function to schedule the next update 1 second later. When the duration finally reaches 0, we immediately call the close break function. The close break function is simple. First, run the onEnd function. Then, destroy the top-level window, making the black screen disappear instantly. Now, we return to our iCare app class. In its break screen method, we create a break screen instance, passing in our onEnd function. But first, we have to define onEnd. Inside onEnd, set paused back to false. Reset time to its original value, 20 minutes. And finally, restart the countdown. One last touch. We call grab set on the top level window. This ensures that, no matter what the user is doing, our break screen takes over, right on top. At this point, the core is ready. In the top level class, we call countdown in init, so it begins immediately when the break screen appears. Time to test. Bravo, it works exactly as planned, but waiting the full 20 seconds for every test is slow, so for testing only, we speed it up, reducing time by 200% per second. Now, the countdown flies, finishing in just a few seconds. With this, our app can interrupt every 20 minutes, forcing a 20-second eye reset break. When the countdown ends, the break screen vanishes, and the user can return to their work instantly. Finally, we restore the countdown speed to normal, and the break reminder is ready for real-world use.
And now let's add the functionality for the buttons, reset, pause, and resume. Let's start with the reset button. When you click it, this function runs and restores the timer back to the original 20 minutes. Let's try the code. When I click the button, there you go. The time resets to 20 minutes. Next, let's create the pause button functionality. When it's clicked, the paused variable toggles. If it's true, it becomes false. If it's false, it becomes true. Simple logic, right? Now, let's make the button text change dynamically. If the paused variable is true, the button text shows resume. If false, it changes back to pause. There's also another important check. The condition verifies the unpaused state and sets running to false. This prevents overlapping countdown loops. Let's run the code and see. Looks good. Try the reset button. Yes, it works. Try the pause button. It pauses. Click again, and it resumes perfectly. There's one more thing I want to do. Make the app run in the background even when the window closes. Here's the magic trick. We use the protocol function and instead of the default self.destroy, we replace it with the withdraw function. This lets our app keep running in the background. Let's run it. Cool. When I close the window with the X button, the script keeps running. It only stops if you terminate it with Ctrl+C in the terminal, or if you use the exit button in the UI. This way, the app stays active in the background. Now that's done, let's move on to packaging our app with PyInstaller. First, run this command, pip install PyInstaller. I already have it installed. Then run PyInstaller, one file, no console, icon, app logo, .ico_scriptname.py. Important note, make sure your icon file is in .ico format, no PNG or JPG. After adding your script name, hit enter. It's running now. Wait for it to finish. Done. It completed successfully. Check your File Explorer. There are two new folders, Build and Dist. Open the Dist folder. And there it is. Our script is now an .exe application. Let's open it. Wow, it runs smoothly. Close it and check the taskbar. Search for 2020. There's our app running perfectly in the background even after closing the window. Now, for the next cool step, making it start automatically on Windows boot. Right-click your .exe file, create a shortcut, rename it if you want, and copy it. Then open another File Explorer window. Go to the C drive. Open the users folder. Open your username folder. Open the app data folder. Open roaming. Open Microsoft. Open Windows. Open Start menu. Open Programs. And finally, open the Startup folder. Here's the trick. When you paste the shortcut in this folder, Windows will launch your app automatically on startup. Paste your shortcut here, and now your app will open automatically the next time you start your computer, and it will run in the background. Great job, we've finished everything. Thanks so much for watching. I hope you found this tutorial helpful. Don't forget to subscribe, like, and share for more videos like this.